So the question says the potassium hydroxide solution has a 0.35 molar concentration, and we're being asked to figure out what the pH is. Now, what to do with the 555 mil value? Now, no matter how much of any liquid you have, you're going to have a concentration that's the same. A cup worth of ocean water versus the ocean itself has the same concentration of materials in it. So what we're going to be asked to do here is we're being asked to go from an OH concentration and we're being asked to change it to a OH hydronium ion concentration, and then we're going to be asked to solve for the pH. So that's a two-step problem. 1 and 2. So let's take first a look at the first part of the problem. In this part of the problem, we're going to change the OH concentration to the H plus concentration. In order to do that, we're going to take advantage of a unique property of water. The unique property of water says that if you take the concentration of the hydronium ion, which is the H plus, and multiply it times the concentration of the OH minus or hydroxide concentration, then you will always arrive at the same dissociation value of 1 times 10 to the minus 14th. So what we do is we plug in the known OH minus value, which is 0.35 molar. Well, 0.35 molar is the same as 3.5 times 10 to the minus 1. That's the concentration of the OH minus. Remember, this number is the same number as 0.35, just put in scientific notation. And you still have the H plus concentration over here. And that's going to equal 1 times 10 to the minus 14th. Now to isolate the concentration of the H plus, we're going to divide both sides of the equation by the OH minus value, which is here. And we'll set that up as follows. Now to do this calculation, one way to think about it is this. I take the fraction and divide it into two parts. I take the 1 over 3.5 and I work then with the 10 to the minus 14 over 10 to the minus 1. I work with them as separate entities. When you do that, you get the following. I take 1 divided by 3.5. That gives you 0.28. Then I take the exponent side of it, and I take 10 to the minus 14th minus a negative 1. That gives you a 10 to the minus 13. And that really is the power of the scientific notation. So this then becomes the concentration of the H plus. You could convert this then to a 2.8 times 10 to the minus 14th to get it into full scientific notation. But that just completes the first problem. The second step in this, if you recall there are two steps to it, The second step says that we're going to convert the H plus concentration to an actual pH value. Now to do that, we're going to use the equation. Here we go. We're going to use the equation pH is equal to the negative log of the concentration of the H plus value. So when we do that, we get a pH that is equal to 13.5. Now, this number does make sense. You'll notice that the potassium hydroxide is a 0.35 molar. That's fairly basic. So a pH of 13.5 would make sense in terms of it being a more basic solution. Let's take a look at the next one. Try again. Go. Okay, here's question number 2 now.